Okay, so if you look over here, okay, first of all, they ask you to complete the diagram above with skeletal formula. So I think I'll go a little bit faster, yeah, because most of you, okay, would have actually analyzed this closely just now. So the first step, okay, if you use concentrated HNO3 and concentrated H2SO4, okay, this is going to be a nitration reaction. So if it is nitration reaction, so we know this is going to be NH2 at position number 1. So this one should be, okay, I will draw first, later the final answer I will include later because, okay, they want the answer in skeletal formula. So I'll just draw first, later, yeah, we will adjust accordingly. Okay, so here, okay, once you get this step 2, yeah, step 2 from NO2 to become NH2, yeah, that is going to be a reduction, which is we use SN and HCl, okay. And once you have this phenol amine, okay, you are going to have a reaction, okay, this reaction, okay, where you are going to form, okay, this structure, okay. If you want to show triple bond and, okay, then plus and then Cr minus, okay, so you can show like that, or you can also show like this, also can, yeah, and 2 plus Cr minus, okay, both also can. Now step number 4 is going to be quite interesting because we are going to use the benzene diazonium salt, okay, and we are going to react, yeah, with naphthol. In this case, this is 1 naphthol. Okay, do remember I taught you about this naphthol. Okay, there if you use normally, if you use this diazotization with OH, which position will be activated? They will activate this particular position. But do remember, OH can activate position number 2, position number 4, and position number 6. But they activate diazotization, they will activate position number 4, okay, because, okay, they will give you more space, yeah, to allow more space for bigger molecules to be attached. So we will actually also look or stick into this position number 4 in this case, because naphthol also will follow the same thing. Okay, for naphthol, okay, and I told you naphthol, you need to be very careful a bit, yeah, because this one, position 2, if you want to draw, it's still acceptable, okay, but I am going to focus on position number 4. There is no position number 6 because it's going to be used up over there, yeah. So I am going to use position number 4 over here, yeah. This question, they can ask you for 2 naphthol also, yeah. If it is 2 naphthol, automatically you should know, okay, I will draw over here. If they ask you question about 2 naphthol, okay, if the OH over here, which position will be most likely will be activated? This position. Yeah, please refer to my notes, yeah, on naphthol, yeah, because naphthol is going to be 2, 4, 6. Okay, position 2 is taken, position 4 is not going to be activated because they say cluttering, position 6 is not, okay, available, so they will come at this position, yeah, so please take note of as well. Okay, but in this case, okay, it's going to be, it will come into this position. So if I want to draw, okay, I will draw, okay, maybe I will put like this, okay, this one, okay, then you have N, double bond N, okay, and then this one will join with, okay, position number 4. So maybe I'll join over here, so I draw, okay, and then there is going to be, if I join over here at the top, there is another, okay, so if I join here at the side is OH. Okay, so let me erase this part. Okay, this is what they want. Okay, and I think this is also quite good already to represent skeletal formula. Okay, now step number 7. Okay, so what do we do with step number 7, Megan? diazosol, diazonium salt, then becoming phenol. What is the region that we use? Maybe Megan is not available. Maybe Jasmine or Megan is there. Megan, you want to try? Or we let Jasmine to try? By very quiet, Christopher.
Sir, is it water?
Yes, water. Yeah. So it's good, Megan. So water, yeah, you need to heat. Yeah, you need to heat. So water you heat, yeah, you will get phenol. Yeah, this is going to be how you prepare phenol. Okay, and then okay, you can see step 7 and step 6. I'll go to step number 6. Is much more easier. Okay, you can see that when you have phenol, okay, phenol is going to be, okay, the OH group is going to be electron donating group. So the electron, okay, from the oxygen, the lone pair, they are going to enter the pi bonding. Yeah, they are going to become delocalized. They will increase the electron density. Yeah, the charge density, the electron density of the benzene ring. So this is going to put the benzene to be more likely susceptible for electrophilic attack. Yeah, because electrophile likes to attack more electron. Yeah, so in this case, okay, the electrophilic substitution reaction will be more favored. So they are going to happen in an easy way. Yeah, you do not need to have certain things like halogen carrier and so on. For HNO3, okay, this one, okay, normally under dilute HNO3 and room temperature, the reaction can happen. But if you use concentrated HNO3, then this NO2 will come to all the position, which is going to be position 2, 4, 6. Okay, they will enter that. Yeah, so this one we will take it as skeletal formula also. Yeah, so they are going to enter this position. Yeah, 2, 4, 6. Okay, and this is going to happen at room temperature. Yeah, no need 55 degrees Celsius. Okay, step number 7. Okay, phenol. Okay, they do react with sodium hydroxide. They are going to give you sodium phenoxide, O minus and A plus. Okay, so if you have O minus, this H, okay, and A plus go there. So what is left over? Okay, you have water as left over. Okay, and then if you come to let's say step number 8, I think this one is easy. Yeah, how do you get CH3 over there? So normally we use CH3Cl or CH3Br. Okay, depending on what you use, then you still need to use the halogen carrier. Okay, and this one can be done at room temperature. Yeah, so you will have, okay, this reaction, the CH3 will go there. Okay, if they ask you what is byproduct, the byproduct is H and Cl, so they will give you HCl. Yeah, so once you get that, okay, they say the methyl benzene, okay, will undergo step 9 and step 10. Okay, if you look at step 10, okay, 1 carbon extra, so 1 carbon extra is this one. Okay, and then 1 Cl only. So it means that one of the Cl only go into the benzene ring. How do I know it went into the benzene ring? Because I'm using halogen carrier. Okay, so the most likely, okay, will be, because I see the Cl is here, yeah, 1 Cl. I will put the Cl here. Okay, and this is CH3. If you want to make sure, please go and calculate, yeah, C7H7Cl or not. Okay, and what will happen here, this one is not a skeletal formula. Yeah, if you want to draw the skeletal formula, then we ignore this one, just put a line over there. Yeah, and that is skeletal formula. And then, okay, if you look at this, okay, Cl2 with UV light, okay, then, okay, you have methyl benzene. Of course, you have 1 Cl substituted, so you will have CH2Cl. So how do I show CH2Cl? Okay, this is carbon, okay, and then there is going to be Cl. So maybe you can draw Cl like this. Yeah, so something like this. Let me make it smaller. And then you have step number 11. Step number 11 is going to be you have methyl benzene changing into COOH. This is going to be oxidation. Now, this oxidation is going to be special because we need to use KMnO4. Okay, but the difference is you need to use alkaline, not acidified. Yeah, alkaline KMnO4. Okay, then heat under reflux. Then you go and acidify. Okay, with dilute acid. Okay, so dilute acid can be HCl, okay, H2SO4, up to you. Yeah, so all this, okay, I have written. Yeah, so now let's look into the question. Yeah, so in this case, let's look into the question. Now they ask you, okay, I will keep the diagram over here. I will actually answer here. So here, okay, they ask you to complete the diagram above with the skeletal formula. Yes, we have completed. Okay, so done. Now, what is the region required for step number 2? You can see the step number 2 here. Okay, this is going to be SN and HCl. Okay, HCl aqueous. How HNO2 is prepared in step 3 and why 5 degrees Celsius is used? Okay, this one, okay, maybe I'll ask Giuliano. Giuliano, how HNO3 is prepared? How HNO2 is prepared?
By reacting NaNO2 with HCl.
Okay, okay, then they will give you HNO2 plus NaCl. And why do we use 5 degrees Celsius, Thompson? Or yeah, Giuliano, if you want to answer also can.
So that it doesn't decay.
Yeah, to prevent the decomposition. Okay, to prevent the decomposition of NaNO2 or okay HNO2, okay, to give you N2. Okay, we don't want that to happen. Yeah, so that's why less than I think less than 10. Yeah, so we choose 5 degrees Celsius. Now, number 4, what is the reaction name in step number 4? Let's look at step number 4. You see this step number 4, you're trying to form the di. Yeah, so when diazonium reacting, so this one we know that it's coupling reaction, but don't go and give coupling reaction because coupling is used, the term is used in textbook. Okay, but in your syllabus, okay, they didn't mention coupling. So I will suggest, okay, if they ask you write the reaction, write down as diazotization reaction. Okay, or you just put like this and then put bracket coupling if you want. Okay, if you want to be safe. Okay, and then what is the region used for step number 5? Let's look at step number 5. Okay, just now already been answered. Yeah, so it's H2O and heat. Compare the reaction in step 6 if benzene is used instead of phenol. So let's actually ask this, Catherine, if you use benzene instead of phenol, what will happen? This reaction, step number 6. Do you think there will be reaction?
Yes.
Okay. Yes, only when what? If you use benzene, benzene will react only when what?
Only if it's concentrated.
I think you forgot the main important thing. Yeah. It will react, yeah, only, yes, good, it's concentrated, yeah, but they already mentioned concentrated HNO3. You need concentrated H2SO4 and concentrated HNO3. Okay, we only have one over there. And you need 55 degrees Celsius. So if you don't have that condition, okay, then you can say no reaction. So you can write down no reaction, but can react with benzene if it's reacted with 55 degrees Celsius, concentrated H2SO4 and concentrated HNO3 is being used. Yeah. So number 7. Okay. Step 7 produces another byproduct. What is the byproduct? Just now I already told you. Yeah. The byproduct is water. So H2O. Compare the reaction in step 7 with ethanol if it is used instead of phenol. So you see phenol reacting with sodium hydroxide. Now, I want to know whether ethanol can it react with sodium hydroxide. So this one, Josh, can you answer this? Will there be any reaction? Ethanol with sodium hydroxide? Surya, we only have 2 minutes.
Yes, there will be.
No. Okay.
No, there won't be.
Okay, ethanol will only react, okay, with sodium. So ethanol is not acidic enough to react with sodium hydroxide. Please remember this, yeah? So no reaction, okay, no reaction. But phenol, it is acidic enough, yeah? And then we compare, like, I think there is going to be this part, the acidity in terms of pKa. So which one is more acidic? Phenol, okay? And then followed by water, then followed by ethanol. You need to know why, yeah? So the pKa over here is low, pKa over here is high. So you need to tell for phenol why pKa is low, okay? Because phenol always form the phenoxide ion, which is going to be more stable because the negative ion will become delocalized inside. Okay, when they are going to be delocalized inside, the position of the equilibrium, okay, will be shifted, okay, to the right to give you more phenoxide ion with the H plus. So H plus is going to be given off. Yeah, so this is going to be the reason for ethanol. Okay, for ethanol is C2H5OH. Okay, they are going to give you C2H5O minus plus H plus. Okay, we know that this is going to be electron donating group. Yeah, the positive inductive effect. Yeah, so they will actually bring the electron closer. Okay, when they bring the electron closer over there, so it means that it will become more negative. Yeah, the negative charge become more negative. This is going to encourage that this one to go and react to give you more C2H5OH. In that case, okay, the H plus is lower. Yeah, so that is going to be explaining about question number 13. So that is done. Yeah. So if I move on, what is the name of the mechanism in step number 8? Okay, step number 8, this is going to be electrophilic substitution. Okay, make sure you know this. Okay, mechanism, yeah. So they didn't ask you to give name like Friedel-Crafts alkylation. Yeah, so be specific. Yeah, be specific. If you want to include, yeah, alkylation, up to you. Yeah, put a bracket like that. Okay, identify the region and condition used in step number 8. So the region is going to be CH3Cl. You use AlCl3, then the condition room temperature. Okay, and then they ask you to draw the mechanism for step number 10. So with the Cl2, yeah. So AlCl3 with Cl2, what will happen? You'll get AlCl4 minus plus Cl plus. Okay, this is my electrophile. So if I have this CH3, okay, when I have Cl plus over there, this one will go there. You are going to get CH3. So this one I erase, okay, it's not going to be stable. So you'll get this, so HCl. So this one will come in here. And you are going to get CH3Cl, okay? So make sure you know how to draw all this, yeah? Now, what is the name of the mechanism in step number 9? Yeah, so what is the name? Maybe Wilson, can you answer this? What's the name? Or Chai? Okay, Wilson and Chai, please answer.
Free substitution.
Yeah. Yeah, free radical substitution. comment on why the Cl group in step number 10 is substituted to position number 2, because Cl is an electron withdrawing group. Okay, so if it is they say why Cl group is substituted to that. Okay, because this is going to be CH3 is going to be electron donating group. Okay, so position 2, 4, 6 activated. Okay, so you can explain that. Okay, this one, okay, why it's going to be step number 10 with nitrobenzene. So you are going to activate, okay, position. Okay, so they say step number 10. Okay, step number 10. So they are going to activate position 1, 3, 5. Yeah, so you can choose whichever, okay, that is suitable over there. In this case, okay, if you have what will happen, the Cl, okay, if the same reaction is used with nitrobenzene, so they are going to go either position number 1, 3, or 5. So I think most likely they will go to position 3 or 5. Okay, number 1 is taken. Yeah, so 3 or 5. Okay, and you tell it is going to be nitrobenzene, and O2 is an electron withdrawing group. So done. Yeah, so make sure you go through this, okay, properly, and then you submit. The group leaders, you submit. Now I just want to check, yeah, who's your teacher for 2 o'clock session?
Mr. Prakash.
Okay, I will ask Mr. Prakash to give me 5 minutes. Yeah, so I will give you a link over here. Okay, I will pass you the quizzes. Okay, so you do this for me. Hold on. Hold on, yeah, I'll give you the link. Check in your WhatsApp, your chat. Okay, please join the link. Okay, to save time, yeah, so those who are joining also, you can still join. Yeah, so I will start first. Okay. Okay. Mr. Prakash, give us 3 minutes, can sir?
Right, sir. Right, sir. Okay,
Yeah,
no.
doing the quizzes. Yeah.
Yeah.
While you guys are doing, yeah, I do see a lot of red over there. Yeah, so it's okay. Yeah. as usual, I'll share to you another link, okay, where you can keep on trying later, yeah, so that you can get better marks, okay. So here, okay, I will just go to the question itself, okay. I'll see which one has more wrongs here. So when I see here, yeah, so I see 12 incorrect here. Now, the question is, okay, what is the region and condition used for the oxidation of methyl benzene? Yeah, so you use alkaline KMnO4 and then acidify with dilute acid and heated under reflux, okay. And then I also see there is a question where what is the region used for the coupling reaction to produce azo dye? Okay, so in order to produce azo dye, okay, you are going to use the sodium hydroxide. Yeah, please take note of that. And then the nitration of phenol happens at what temperature? Okay, I think most of you would have answered 55. It's wrong, yeah? Room temperature, yeah, room temperature. So please take note of all these questions, okay? But you can try them again, yeah, no problems with that. I will open I will pass you another link. I will open it until 9 o'clock today. And I will also ask you to write a reflection on this worksheet later. Okay, but first, okay, the group leaders, you take note, whatever things that we discuss, you adjust accordingly, you submit to me 6 o'clock, by 6 o'clock today, yeah. So each group leader submit the worksheet to me, yeah. So that's it from me, okay. I will pass to Mr. Prakash now. Okay, hold on. Mr. Prakash, you are the host now, yeah?
Okay,
Okay,
sir.
see you guys. Yeah, see you, Mr. Prakash. See you.
Thank you, sir. Bye.